Thanks. Someone clapped for that. Thanks, Omar. It's a very special name. I work upstairs at Society of Work. And if you have not ventured past the 5th floor, well, we're always glad to see you here on the 5th floor on Thursdays. But I encourage you to check out Society of Work. We are a shared office space for freelancers, remote workers, and anyone who's building anything awesome. So I know a lot of you work from home or work in coffee shops, and so we provide a place for you to get out of that routine, get out of the house, and have a great creative community. So we're excited to announce that we're adding a 2nd floor. So we have 18 new offices for growing teams. So if you have a remote team and you're kind of working all over the city and you're looking for a place to come together, we'd love to show you what we've got and bring you in, connect you to our community. So we have a lot of awesome people working in our space. Carbon 5, who you know, was one of our first members when we started up, and they've got an awesome growing team. So they're a great example of joining our space and being part of the community. They've done a lot of great things. And so if you want to learn more, I'm going to put these coasters over there. It gives you a free work day in our space. So come check us out. At 1 o'clock, we'll be upstairs to give you tours. Thanks, and enjoy that macaroni and cheese.
Wow. All right. How are we looking on the biscuits back there? Huh? Is everybody getting one? So if you don't get one today, you should probably beat up the other people that are here because somebody didn't RSVP in the last 24 hours. I usually do the order on Wednesday for the biscuits. So if you can RSVP by Wednesday, that'll help me to get a good count and make sure that everybody gets a biscuit. Okay. Aaron, you want to come give us a shout out here? Everybody give it up.
So for those of you that don't know, Techtown has moved from near the aquarium down to the 2nd floor. So come check us out. So Techtown is a place where young kids can come learn about coding. We do HTML, a little bit of JavaScript, Python. We teach robotics, 3D design. What else? So if you work at Techtown, raise your hand. Dana, Sydney, Travis. So come check us out.
Ooh, y'all are weak with that applause today. Gonna have to get you. Huh? Oh, excuses. Sad. It is a hardware issue. Anybody else? Any other meetups coming up? No? All right. Well, without further ado, I want you to give a warm welcome to one Mr. Brian Newton, who works for, yeah, go ahead. This is a good time. Why not? There it is. That sounds good. Yeah. Yeah. Oh, man, that's what I'm talking about. Getting this pumped. So he works for Turner and works on some of the products for CNN. So he's going to be talking with us today about GraphQL. And I know that's why you're all here. So, Mr. Brian Newton.
All right, can you hear me in the microphone here?
Sounds
All
good.
right, so let's start out. We want to talk about today what in the hell is GraphQL, and do we really need another query language in this space? So first about me, I've been working for 17 plus years in software development. I've currently been working at Turner for about 9 years, doing a lot for NBA, CNN, a couple other properties. And I'm what you used to call a generalist. I think they call them something else now, but that means I know a lot about a lot of different technologies. And then when I have to, I can specialize pretty quickly in something, which is what brought us into GraphQL at Turner. First of all, let's talk about why we brought in GraphQL at Turner. We needed a new query language for our RESTful APIs. We invested in NoSQL, RESTful APIs using JSON, microservices, all that good stuff. The problem is we still have relational data. So a section like the CNN homepage will have references to a lot of other pieces of content like articles, images, and videos. And so with early iterations of our other RESTful APIs, the client had to build their own compositing layer. They had to retrieve the section, look through it, get all the reference IDs out, pull them out into a separate batch call, make a second call, sometimes a third and fourth, back to our API, ended up being really inflexible. Also, with the large focus on mobile, we needed a way to allow the clients to get just the data they need and not have to do all the processing and secondary calls to get all of the data in order to just say, just show the image, title, and URL for that, secondary piece of content on the home page. So what is it? GraphQL, according to the website, is a query language for your API. It sounds pretty simple, but let's go through some of the properties of it. It's declarative. Query responses are decided by the client rather than the server. So a GraphQL query returns exactly what the client asked for and no more. Here we've only asked for a hero and the name of that hero, and that's what you should get back, hero with the name. It's strongly typed. GraphQL query can be ensured to be valid with the type system at development time, allowing the server to make guarantees about the response. It makes it easier to build high-quality client tools. I know with NoSQL and schema lists, everybody's all excited until they realize that schemas do matter. So we have, schema, representation of the capabilities of GraphQL server, and then a couple different other types in there like scalar, object, interface, union, enumerated, input object, and list. And out of the scalars, they have the typical, end float string, boolean, and ID. We won't really talk about input objects. That's where you get into allowing writes through your GraphQL API. They're called mutations. You can look into that later, but I didn't really have time to fit that in. Also, I haven't done it yet, so I didn't really want to talk about it. All right, also, it's compositional. A GraphQL query itself is a hierarchical set of fields. The query is shaped just like the data it returns. It's a natural way for product engineers to describe data requirements. So here we have a GraphQL object type, if representing a human. You have a description that becomes important later because there's some nice introspection capabilities. And then we define some fields. We have an ID. We're telling it can't be null, and it's going to be a string, a name, another string. And then you have friends down here, and these friends are a list of another object type. So we're composing our schema out of these objects. So to sum it up, it's a data query language and runtime designed and used at Facebook to request and deliver data to mobile and web apps since 2012. It's hierarchical. The query is shaped just like data returns. Product-centric. It's driven by the requirements of views and of the front-end designers, engineers that write them. You have client-specified queries. Queries are encoded on the client with field-level granularity, returning exactly what is asked for and no more. That becomes very important with mobile. Backwards compatible. Client-specified queries simplifies managing backward compatibility guarantees. If a new field's added, you don't have to go change a whole lot. You have to add it to your schema. It doesn't break anything. You have structured arbitrary code. You can expose fields that are backed by arbitrary code. We'll see this in our demonstration with resolve functions. It's an application layer protocol. It does not include REST, HTTP, any other thing like that. It just takes a query, executes it against the schema, returns results. The rest is up to you. It's nice. You can fit it in a bunch of different places. Strongly typed, as we said, and introspective. Clients and tools such as Graphiql, which we'll also go over, can query the type system using the GraphQL syntax itself. It makes marshalling into types less error prone. So let's do a demo. Hopefully I didn't screw this up. So let's look at our first demo. Can everybody see that okay? Yeah, sounds yes. Bump it. All right, we'll bump it. All right, what I did for this demo is I created 3 routes. We'll go through each one. This is your nice typical hello world example. I had to do it. I think it's required at this point. V2 will get into a more complicated schema using actual data. In this case, we're just going to pull JSON files. We're not going to try to talk to a Couch database or a MySQL backend. Just want to give you an idea of how that works without making it too muddy. And version 3, we're going to get into something called DataLoader, and I'll save that for the second part of this talk. So what we are using is Express with the Express GraphQL module. It's by far the easiest way to get started. You can use this again. It doesn't have any requirements. We use it at Turner with Happy, but you can use it with any of these. Express is just the easiest way to get it started. As you can see, turning on Graphiql is just a Boolean. You're going to create this GraphQL HTTP object from Express GraphQL, give it a schema, and give it a root value. That root value is something that we're going to see in every resolve function. Everywhere we execute that arbitrary code, it's a good way to just inject your dependencies into your schema, into your resolve functions. So let's go look at the V1 schema. We'll do the database first. And here's our database. This is all we're doing. We're exposing one function, log something. It's going to just throw out a console message so we see what's going on. Nothing too exciting. But that's what this is the DB object that we're passing in to the root value there. And then we're going to look at a schema. Very, very simple. Hello world. We are going to define our schema down here. This is where we tell it, this is our query part of our schema. You would also have your mutations and other stuff if you use those. And then you have our query here, GraphQL object type, give it a name. Everything has to have a name and it has to be unique in your schema. And then we're going to expose some fields. And the first one, the only one we're exposing is this hello field. We're going to tell it its type, which is that scalar, GraphQL string. And we're going to do a resolve, and we're expanding into that root value, which is the first argument. And we're going to do that, call that log something method, and we're going to return world. So I usually use curl, but I decided to get fancy and use Postman here. Everybody familiar with Postman? Everybody seen it? All right, so we have our V1. It'd probably help if I go and start the server, so let's do that. Start my server, and then we'll go back to our hello world example. Important thing to note, I am using this content type application GraphQL. Sorry. And if you don't do this, if you use the xwww form URL encoded, you just have to put query equals in front of it to give it that name value pair. But otherwise, that's another cool thing about an Express version of this is it gives you that out of the box. It gives you that application GraphQL MIME type. We're good to go. So we're going to run this example. It's a post. We're going to send. And you see we got back our data. It just says hello, hello world. So very, very, very simple. So let's, any questions so far? Before I go on to the complicated one, more complicated one? All right, more complicated. Let's look at our version 2, which has a more involved database. Inside our database, we have some data files. We have movies. GraphQL loves their Star Wars references, so I just kind of went with it. And we have one movie in this array, and it has an array of actors by ID. I'm going to show you how this relational data ties in. And then we have our actors. We have a couple different kinds of actors. We have human actors, we have droids, and we have aliens. And you notice in each one of these cases, it has a different set of fields. For humans, we have first name, last name. For droid, we just have droid ID. And alien, we just have name. So in our database, we pull in those two files. And I'm going to export a couple of functions. Get movie, which is just going to match on title and return the title. I'm returning it as a promise because typically what's going to happen is you're going to go talk to CouchDB, you're going to talk to Mongo, something, and you're going to want to get a promise back. I'm just kind of flubbing it here and showing you that promises are okay to return in a resolve. Same with the get actor. I'm going to take a single ID in, tell you that I'm resolving that ID, match that ID, and then return that one ID so that we can see what's going on. So that's our database. We have two functions here, get movie and get actor. So let's go look at our schema. Very similar to what we saw before, but in our fields, we're going to expose a movie of type movie. I've required a movie. Remember, it's compositional. I'm going to pass in some arguments. I want to know what the title is of the movie you're actually looking for. In this case, we only have one, but this is how you pass in arguments. And I'm going to have a resolve function, and I'm taking the DB out of the root value, which is the first, and then the title out of the arguments, which is the second argument. There are more arguments on there. One thing that's really crappy about the current reference implementation is they like to change these on you every once in a while. So when you go, of course, they do it with a major version bump, so it's not, or a minor version bump sometimes. So it's not too bad, but a good way to do that is just kind of console dump all the args. Or you can go look at the code. It's all open source. And I'm going to return one movie in here from my database. Now, let's look at that movie. This is a movie. Again, I've given a name. It's unique. I get fields, I have title, And I have actors. Actors is now a list of actor objects. And we look at the actor, and each actor, remember we had that movies JSON, I can pull that back up again. And in that you had actors and you just had ID, right? So I've exposed ID, you can grab that if you want. And then I have this ref field that I just kind of popped in out of nowhere, right? I'm going to tell it's an actor union because I want to be able to differentiate on the different kinds of actors. And I'm going to resolve, again, the parent is the parent object, so I can get the ID out later. Args, we don't have any really here. Context, don't have any, I can just ignore those. And I'm getting my DB out of the root value. Now this argument, if you look at the whole thing, dump it out, that's got a lot of very useful information if you need to get more complicated. You have your full AST, you have your field level AST, it tells you where you are in your execution, some interesting stuff like that. But it's there if you need it. I'm going to get one actor. Okay, so and then the actor is going to resolve to an actor union. This is where I differentiate. I want to know what type it is. So I'm going to resolve type, get that type out of that object, and in the different cases, I'm going to return the different union types. Typically, you'd also have a default here because, you know, JSON, you never know what kind of crap you're going to get back. So you want to protect against that. We have an unknown type that we expose. That way, on testing, we can ask for that unknown type in our query and see what comes back in case we miss something, there's something bad in our data. But we don't, the people who actually call and use our API don't ask for it, so they never see it. They just don't see anything there. All right, so, and then these are pretty simple. ID and name for alien, ID Android, human. Okay, so cool, let's go execute that. In this case, we're going to ask for the movie with the title. That's how we pass in arguments. Title, actors, ID, ref, and in this case, we just say an on droid type, we want droid ID. So what's going to happen here is we only care about the droids. We don't care about the humans, we don't care about the aliens. So we can tell this, we can, as a client, get exactly what we want back. And if we send that, you'll see down here, you have the Star Wars movie, and we only got the droids back. If you wanted to then go ask for, say you all of a sudden care about the humans in there as well. Let's just get, really anal about my braces, I'm sorry. And then we're going to do that, and see now all of a sudden we get the last name of each one. So I've told it exactly what I want to retrieve, and it only gives me what I've asked for. It didn't give me the one alien I have in there down at the bottom. See, it's just okay, that's it. Any questions on that before I move on? Well, if it's not there, you could, again, go in and see what they asked for and exclude it if you want. We don't have this problem. They just ignore it if it's not there. In a lot of cases, they'll just see that there's content there and they've asked for it or they haven't, and if it's not there, then they don't need it, you know, that kind of thing. In real world, you know, live code right now with the CNN's new mobile app, we're using GraphQL. And they're only asking for very certain types because they only care about some things in mobile and not others. So, but anyway, any other questions? So the ... on in the actual query, that's part of the GraphQL specification. And it's just saying on the droid type, when I encounter a droid type, I want these fields. When I encounter a human type, I want these fields. It allows you to differentiate. There's other things in there like aliases and some other very interesting things to get you around some certain situations with the way references collide. So. It's again part of the GraphQL spec. Yep, you can put them in if you want. I believe. I don't think it really, honestly, cares. It works just fine with comments. It's just part of the spec. Yes? Sure. Yeah, if you want. You can run arbitrary code in every one of these resolves. And on this ID field, like if you wanted to put a resolve on it and check authorization to that field, you certainly could do that. Again, it doesn't care how you run this thing. It's just going to run the backend. We put, well, we call them bearer tokens, but they're really just a shared secret at the moment. We're expanding that. But we could then authenticate and authorize somebody and say, you can't have these fields. Sure. Yeah, you could do, like he asked if it'd just be an express thing. Again, we use Happy, so we use the authentication in Happy to do that, to authenticate the bearer token. We don't do much with it yet, but you know, it's all possible, sure.
Hi, so I just got in, and you may have already covered this, but from a broader implementations perspective, you know, I understand that GraphQL kind of like aggregates your, you know, over REST queries. But on the back end, is it still going to specific REST services, or is it like kind of one call, and on your back end you can just get everything in one shot?
Sure. What we've done here is I put that console log in, and you can see where I'm making the calls individually. And I'll get to this because this is a problem we had. But I'll get to this shortly. But you can see I've got the for in there twice on purpose. I want to show how duplicated data works in our in our movies JSON file. I intentionally put for in there twice because I want to show how that works with the next part of the presentation. So let's get into that. All right, so DataLoader. Anybody who's done any kind of work with databases know that flooding your system with single ID calls for large data sets, it's not as performant as doing a batch load. You know, with SQL, you have your wherein. We usually expose batch APIs, especially with, you know, HTTP. It's so heavy for the setup and teardown of each HTTP call, and you're going over the pipes, and anyway, it's bad. So we wanted to batch load in the resolve, you know, through the resolves. We tried to do it by hand at first. We were inspecting the AST at a level higher than we're actually trying to do the resolve. I was using like a JPath, jQuery, or JSON path to find where the things are, to see if we actually care about those dependencies, and then getting the batch load together, executing it, and then populating the data into the data model. It was messy, and you lose kind of that nice view of your schema where you see the resolve happening where it's actually being resolved. You could set up a visitor pattern, all this stuff. Anyway, it got really messy. So we explored it. One of our developers went and tried to write his own. You know, I'm a buy before you. You know, I like to buy stuff off the shelf. Facebook provides this thing called DataLoader. Ended up having everything we need. DataLoader uses promises to promise a result at some point in the future. The function passed to the DataLoader constructor will be a function that gets called on each tick. So when you set up your DataLoader, this is your batch function right here. The way it works is you call these loads all throughout your code, and then on next tick, it will take all those IDs, and it'll pass them off to your batch load function. So this is pretty cool. We played around a lot with it because we were worried about the process.nextTick not happening. Like we didn't know how the code is actually being executed in GraphQL. I went and looked at the code. It was executing it all in one thread, all these resolves. So all the resolves at a level are going to get executed in a tick. So then the next tick, it's going to call them, you're going to return your promises. When those promises get resolved, you have your data. So it has a couple of options on it. You know, even though the power comes from being able to load a function anywhere and have this batch, you can turn it off. It's kind of good for testing, I guess. Cache enabled or disabled. This is a very important option because we found with cache disabled, there is a kind of a unexpected but expected undocumented feature. And then there's a max batch size, which when we first turned this on and didn't put in max batch size, we crushed our back end. We have like 300 references we're trying to resolve against our back end, and trying to do those all in batches, like at 150, 200, 300. We're getting 500s back from our back end. So having max batch size set is almost always a good bet. And we did load testing against different batch sizes to kind of see where our sweet spot was. So here's the undocumented feature. With cache disabled, your batch function gets all the keys, even the duplicates, and we'll see this in a second. So I've asked for 4 twice. It's going to call for 4 twice in the batch load. Sometimes, especially with SQL backends, when you do a where in, you can give it that ID twice, and it's only going to return 1 record, not both records. And DataLoader relies on that array of results being the same as the array of IDs. Some things to keep in mind. And know your cache strategy. We do a cache, and then we do a very simple set interval to clear the cache every so often. Also keep in mind that we have 20 of these running right now. We can scale out pretty far with this. Keep in mind that each node has its own memory cache. We've thought about forking DataLoader to take advantage of like Redis or Memcached to share cache, but so far we haven't seen the need to do that. In our load testing, it's just not come up. Sorry, guys. So let's do another demo real quick, and I will show you DataLoader in action. All right. So here's our V3. The data's the same, movies are the same. We still have that duplicate in there. This is our new database file. As you can see, we still export the same 2 functions, getMovie and getActor, for the database. What we've done is create a DataLoader object. Right now we're going to have cache disabled, so I can show you how that works. Our new DataLoader constructor, we tell it the getActors function. That's going to be our batch function. And then we pass in those options as the second argument. Our batch function, we're going to do exactly what we did before, except we're going to match on all IDs that they asked for and show you how that resolves back. Okay, so our schema has not changed 1 bit. All we did was plug in our DataLoader function, and we changed our getActor to call the DataLoader.load on that single ID. So it's going to call each time we hit that resolve for that single ID, but it's going to make the batch call. Also, notice I set max batch size for 3. So if we want to look at that in action, and just to make things interesting, I kind of switched up the query here. Instead of just listing out all the different actor types under actors, I wanted to show how you can use a fragment to create reusable pieces of query. In our data, we have these rich text paragraphs that have about 5 fields with subfields and all this other stuff, and they show up everywhere. So we create 1 fragment. Everywhere we need that fragment, we just do ... actor frag. All right, so let's execute this, and you can see we got back all of our data, excuse me. Just like we did before, nothing changed there. But let's go look at how it was actually called in the back end. You can see before where we were calling individually, and this is where I started with the second one, resolving actors, and you can see it does the batches of 3 for me. And you can see it called 4 twice, because it doesn't understand the function to deduplicate those is in the cached part of it. So let me turn on caching, and let's see how that changed. I'm going to start the server. We're going to go execute our query again. See how that changed. Okay, this time we have cache enabled, and you can see 4 was not called twice. So that was just an interesting undocumented feature side effect of the way it was implemented. There's an issue out there to fix that, but the author indicated it's quite complicated. Okay, I just called it again, and it did not call any of my resolves again. That data is cached. I don't have a TTL on there, it's cached forever until this thing restarts. That's why cache strategy is important. So that is DataLoader. Any questions on that before I move into Graphiql? Yes?
Arbitrary conditions on your statements, like I want to find the people who are older than actors who are older than 25, or would you have to code that into as a parameter into one of
You have to code it as an argument and then have your resolve function. In our case, we want pagination, right? We want say the 50 top by publish date articles, right? Say we want to expose that, but they want to get the next 50. So we have start and rows as arguments. We have some other arguments like Boolean flags to tell it whether or not we want certain kinds of data. So yes, you do have to account for that. You can't just arbitrarily say, give me this and not that. You have to account for that in your schema. Schema. Yep. I mean, if you wanted to get fancy, you could have an arbitrary way to evaluate, but then you're getting into eval territory.
That's not written into the GraphQL.
No. No, it is that in the fact that you can take arguments in and decision off of them, which we do quite often. But it's not in the fact that there's a way to slice and dice your data like you would with SQL or something like that. So, anything else? Any other questions? And we'll go into Graphiql, which is like Swagger for GraphQL. All right, let's do that. Introspection. So one of the good draws of one of the cool things about GraphQL is there's an introspection API that comes for free with your GraphQL implementation. There's a way to query for that information. We'll see that in a bit. But you also have Graphiql, which is like Swagger for your GraphQL system. So it's an in-browser IDE for exploring GraphQL. It has all this cool stuff, syntax highlighting. It actually gives you the red squiggly line under things you're doing wrong. Real-time error checking, highlighting and reporting, automatic query completion, and you can run and inspect your query results. So you can go, I'll show you an example on the one I just wrote, but we also have the GraphQL, this one, SWAPI GraphQL, and you can go to that and try out all of this stuff against their Star Wars database, which is a lot fuller than mine. But I can show you this in action on the little demo I wrote here. As a side note, I went and looked at some of the demos that exist out there. There's a ton of them, but all of them are a lot more complicated than I wanted just to get into the nuts and bolts of GraphQL. In the JavaScript world, you've got to have a million frameworks and extensions and Babel and everything else. I wanted to get all that out of the way and just do something very simple. So that's why we have what we have. All right, so with our server running, you can just go to localhost. Look at that. Great, and it's nice, pretty API for your GraphQL implementation. Over here, we have a documentation explorer, so you can actually go and search the schema. You can click into each one of these and see what's underneath it. So movie subtitle. So let's typing during these things, but we'll go here. So we want to start with movie. Cool. Completion. It's got a little red line over here, so it means something's wrong. And it says, must have a selection of subfields. Did you mean movie? The thing I did wrong is I should have made this title, wrapped it with a GraphQL not null, and then it would have complained at me that it needs a title to function. All right, so title. Okay, cool. Let's see what else we got. Actors. Let's do actors. Complaining because it wants more. Let's just do ID for now. Execute, and we can see our example. So that's cool. What's also really cool is that you can use your introspection tool to introspect your schema. So get into here and you start, let's go look at the schema, start looking at the types, name, so we can go look at our schema using curl or any other tool. We can build our own tools around this if we want. It's one of the nice things about having a strongly typed schema on top of your RESTful API. It's a good way to define what you want the world to look like. With those resolves behind everything, you can make it look like however you want, no matter what the data is behind it. So that's Graphiql. Any questions about that? I mean, it's pretty simple. As you saw in the server I'm running with Express GraphQL, all you do is set Graphiql to true, and it gives it to you. We've had a little trouble getting it into Happy. Happy just serves JSON. It doesn't like serving HTML, so it takes a little more work. There are ways to do it. We just haven't fought that fight yet. All right, so final point. That's my son giving his death stare. GraphQL gets us out of the business of endlessly changing our API and return models. What we were doing before, especially for mobile, is every time they want a new field, we had to add another damn field. And it's endlessly chasing it, and it was always in code. It was a pain in the rear. This way, we can just expose all of it through an API that has introspection. They can figure out what they need. They can decide what they want to return. If we add a new feature, if we add a new type, if we add a new field to a type, they don't have to know about it until they want to know about it. Their query doesn't break. We have had a breaking change or two in the past, mostly when we want to rearrange things, but typically you're not going to break anything that they're doing. Another good quote, it's a liberating platform for product developers. With GraphQL, no more contending with ad hoc endpoints or object retrieval with multiple round trips. That was very important to us, the multiple round trips. We're still dealing with that, so some of our legacy APIs. Instead, elegant hierarchical declarative query dispatched to a single endpoint. It's been very nice for us so far. So to answer our original question, I would say yes, we do need another query language to address the gaps in how we relate data in our new NoSQL, key-doc, data store schemaless world. Here's a couple useful links. I will post this as well as my demo project up in the meetup. You can go look at it later. And thank you. I'm pretty much Newtonius everywhere in the world, all the social platforms. So that's it for me. Do we have any questions?
I saw for the server side you're using Node. Have you done? Sorry, right here.
Yeah.
Have you looked at any of the GraphQL bindings for other things like C# or the other ones that are out there? Have you worked with any of those?
We have a developer who is in love with Go, and he's looked a little into it, but we haven't really explored it too much. In our shop, we kind of do the same thing Netflix does. Unless there's a good reason to use something other than what we're already using, we just tend not to do it. So we're mostly Java and Node now, and we didn't want to move that way. We had some performance concerns going in with this. We've been able, especially with the DataLoader, we've been able to alleviate a lot of those performance concerns. We have some nice tuning knobs we can now do with the max batch size and the TTL to really throttle that back if we want to set the TTL to 5 minutes and protect our service or protect the service behind it. We can do that. So to answer your question in the extremely roundabout way I just did, yes, we have. No, we haven't gone and seriously looked at any of those other options. But they're out there. There's a lot of them.
Thanks.
You're welcome. Any other questions on GraphQL or anything we do? Yes, in front here.
You mentioned Netflix, so did you evaluate any other libraries or type of query languages like Falcor or anything like that?
No, we didn't. Yeah, we looked at GraphQL. Basically what happened is I did a proof of concept to show how GraphQL could be used. We needed a solution. I already had working code. We just kind of ran with it. We were very iterative. I'm a very iterative, agile guy. So we kind of dove in, built it, solved our needs, and ran with it.
Earlier you mentioned as kind of an example the CNN homepage as an example. Is that something that's active on the CNN homepage? You're using
For the
GraphQL
mobile
as the
sites,
backend?
yes.
Cool.
Yeah, the latest mobile application that just launched last week. Of course, I was in the DevNexus conference last week, so of course we're going to launch something. That's the way it always works. So yeah, we launched the new mobile application last week, and it's all running on GraphQL now. We had another question. Did you still have a question? No? Anybody else? Okay, well, feel free to reach out to me if you want to talk about our load testing strategy and how we arrived at what we wanted to do with this, any of our caching strategies, any of that stuff. I love talking about it. So thank you very much, guys. Appreciate it.